Hello, welcome everyone in this new episode. Today we're going to continue with the HomeCtrl application, the WebAssembly version of this application at least. In the previous episode, actually, we already mentioned this and we've been working on this a new implementation, and this was the previous blog article that I have available here. And so we're moving to this new one. So considering, okay, let me fix that already. All right. So yes, the idea was to try to start thinking about how you would handle the Brotli compression for your WASM file. In fact, we can maybe just show that in this folder, I think it is web app view. So when we perform the compilation with unscripted, this is going to produce this WASM file, and that is the application file containing everything you need to run the application with Qt and your actual code, or also, well, everything. And as you can see, it's a pretty large file. It's not that large, but I think the idea with a WASM file is if you start to build a game or something like that, it could technically become pretty large. And so compression with Brotli is going to bring this significantly down, which is very good to take. So yes, the idea was to try to get this on Rails. First thing I tried was to use Brotli as a dedicated application, because I was actually also building that from sources. I don't know why in the first place I had to build that from sources. I think in when you build free type, you might have a dependency, an optional dependency on Brotli. I think, I'm not quite sure. So anyway, we have in NerveProj, so this is something that anyone can build actually using the NerveProj project. So in the libraries, I think you have that available in all the free flavors here. So MSVC will find Brotli, and this is the one I was trying to use, in fact, the executable file here. Let's just check very quickly where we need Brotli, just to confirm that I'm not saying anything nonsense here. In the builders, let's check free type. Yes, in free type you may use Brotli. The decoder, I guess it means you can actually use compressed font file somehow. Yeah, didn't push it much further than that on this point. I just added the dependency and that's all. Anyway, so with this tool you can execute a command like this one. So this NDP Brotli is basically just going to run this, and then you pass additional command, which are those elements here. So K is for keep, I believe. You keep the original WASM file. -C is for to select the best compression, which is a compression level 11, I believe, by default. I don't know, and maybe it's doing something else, and I found that it's usually the best command to do the compression. You just specify Z here, and then you specify your file. As I said, this is going to reduce significantly the size of the WASM file. Yes, problem with this is this is not really something I could use in a portable way, because obviously I was using the full path to my MSVC build application here. So I thought it would be better to try to build a Python script where we could use the Brotli package, because you can actually install a Brotli package for Python. So to do that, I started to build another script, which is Brotli encode like that. It's going to use a dedicated environment and just going to that's wrong actually. You cannot use Brotli here. I think I changed that name and I renamed that to Brotli handler. So let me fix that. All right, fixed. You can't use Brotli.py because you are already anyway trying to import Brotli package in this in your own file here. So this is going to produce circular dependency, which is not good. Where do I have that? I can just show you maybe the file, the complete file. No, that's a builder. And there. So that's why you cannot call this file, just Brotli. Anyway, I started to build a dedicated handler for that. At first I was focusing on the compression support, but it was no big deal then to simply introduce the decompression support also. So there are those two accept the commands on this builder, on this component or handler, but not builder. And let's see, so when you request the compression, you need to provide an input file. You may provide an output file, but if you're not providing that, you're going to get a default output, which is just input file with the BR extension. Then we need to specify some parameters to perform the compression. I had to actually investigate a little bit on that because yeah, I was using ChatGPT to get the base compress command, and it seems that this compress command here has changed with time. At first you were supposed to provide a full dictionary of those parameters, but now you actually just provide that on the as arguments, as separate arguments for this compress command here. I can't access that here because Brotli is not part of the Python environment used for this specific project here, but I think I can anyway show you that, because if we go in the dedicated Python environments, we can go then in Brotli lib set package, and we have the Brotli file here where you will find this compress function defined. So you're just providing the string, which is what you want to compress, and then you have those additional arguments. Actually I could just not provide them at all because this is really what I'm providing by default, but yeah, this could be further customized here if there is a need for that someday. I don't know, we'll see. So we're just compressing a string, in fact, here. It's yeah, this is also something that was different from what I found now in the indication on how to use this compress command, because what I found was you could provide a file name and it would compress a file, but with this version here, it's not really how it's working. It's compressing a string, so you have to first load your file content as a string in Python. You compress that, and then you're going to get an output string for this, and you want to write this output string as another binary file. So this is what we're doing here. We just read this binary file, this binary input. We get the content that we're going to compress, then we get the compressed string, and we're going to write that as simple binary data. And that's it for the compression. So I didn't have so much trouble with that, I guess we could say. So started with simple skeleton here, and then adding the function progressively. So the compress function was like that, and the decompress function is like this. For the decompress function, it's even more simple because there's no parameter that you can provide. So you just call Brotli decompress with your compressed data, and it's going to produce the decompressed data, which you still want to write then as a I guess it might not always be a binary file at the end. You can always write that as a binary file, of course, but you may also write that as a text file in some cases if the input data was text, I guess. I guess it's just better to just keep binary here anyway. And so I gave this new component a few tries, this new script I mean. So I was trying to do the compression and it was working just fine. Just note here that the compression part can take a significant time, whereas for the decompression part it's extremely fast, so that's a good thing, I guess. Next, yes, the thing is, I'm going to build this WASM file, the Unveil WASM file. Every time I do an update and a compilation of the Unveil project. No, not this one. This is the desktop version, so not where we want to go. So this one is the WebAssembly version. So you're going to rebuild this file every time we do the compilation. So every time this is done, you need to recompress. So from my perspective, the best way to handle that was to try to do it in the script that I'm using to start the WebAssembly version. So I spent some good time on that, and I think I have already described that somewhere. I just don't remember where. I could look if someone want to get some detail on that. But anyway, the HTTPS server, I think it's already in Nerve Proj. NDP, yes. So this is available online on GitHub if you want to have a look at what's happening in there. So basic idea here is you're going to call this serve directory. This is I mean, I can show you that here. If I do the compilation here with unscripting, so that's going to rebuild again the Unveil application. I have modified. I am still modifying a little bit this application, so you get different content for those files here. So it's rebuilding, actually rebuilding. While I'm at it, one thing we can notice here is that building with unscripting can be a bit slow. So you see almost 30 seconds here. So now I have updated this, no, where is it? This Unveil WASM file, and if I am to try to run that, don't remember the command, never, this one, Unveil serve Unveil, that's going to use this HTTPS server here, and as you see, a preliminary step now will be the update of the wasm.br file. So it's going to check what are all the available wasm file in the directory of that you want to serve. Actually, there's only one for now. Okay, so that's the actually this is really the updated design. It's not really the stage at which I was when I wrote this blog article, so I don't know if I have other picture in there, but anyway, the idea was to demonstrate the compression with Brotli. So yeah, I did update this part. Also, then if you have to use Brotli in case the WASM file was updated, or if there was no .br file at all the first time, for instance, if you have to use Brotli, it means that this package must also be available in the Python environment that you use to execute the serve command here, so I have also updated that. In fact, if we go in the configuration in nerve still, come on, that's too many things. Nerve config, is it here? Brotli env. So this is to encode and decode. This is the Brotli environment. And no, I think it's in Nerveland that I have defined the new command to do the, to serve either crypto view or view. But now, as you see, we're going to use this Brotli env, which is defined in NerveProj anyway. So we will have Brotli available. Is there anything special to mention here? Not really. We use find those WASM file. We check if there's an existing BR file, and if not, we just generate the first one. And otherwise, we just try to compare the modification time of both files. If the WASM file is newer than the compressed version, then we do recompress. So we do an update. Okay, what was next? Oh yeah, once you have a Brotli compressed file, you will need to decompress that on the JavaScript part. And actually, to do that, I think the normal way to proceed is to set up your web server on one side, and then on the browser side anyway, it's going to be handled automatically with recent version of your browser, I guess. So you have to set up this communication channel so that the web server is going to serve the compressed version of a given file if it was requested by the client. So the client is going to make a request stating that, okay, I can support Brotli or gzip or whatever as a compression for this communication that we want to start. And the web server would reply, okay, if you support that, then I can provide you the file with Brotli compression. So be prepared to receive a stream of data, which is the compressed data. Then on the server side, again, I guess you can still have two options. I think you can either have the server compress the file on the fly and serve this compressed stream, or you might even be able to just point the web server to an already compressed version of the file and request it to serve that directly. And on the client side, you would still just decompress progressively, and you get a stream of compressed data which is decompressed by the browser itself. So that will be the, I guess, optimal, standard, best way to do it. But I don't really know why exactly. I didn't feel like modifying too much the server part for now, so I thought, okay, why not just consider that the Brotli compressed file that I want to serve is just a regular file. I don't want the server to know anything about it. I just want it to always serve me as this wasm.br file. So bypassing all the setup that you technically should do on the web server, I guess, and just requesting always this wasm.br. So point is, if you do that, when you get your reply, then in JavaScript, when you get your response data, this is the compressed data. The browser is not going to decompress anything. It's just a stream of bytes from its perspective. So you need to do the decompression yourself in JavaScript. That's why you need Brotli the decompressor, at least of Brotli, available in JavaScript. I spent some time to try to figure out how you would do that, because yeah, that's a bit going against the mainstream idea of how you should proceed, because everyone is always setting up a Node.js environment to get Brotli, build that as part of a project, and then get this browsified and available, yeah, as a single JS package that the client would load, and you would get Brotli, poof, available out of the box like that. I absolutely didn't want to go with setting up another MVP project with in this case, so I needed to do that manually somehow. So as I said, spend some time working on that, but if you try to dive a little bit deep in the official repository for Brotli, you will find those examples. And so you have the GS code, for instance, here, and this decode.js and decode mean.js, this is actually providing the full Brotli decoder in JavaScript. So if you try to use this file, you will have, I think it's at the end, the Brotli decode function, and this is what you can use to do decoding in JavaScript. But point is, this JavaScript file here is set up to be loaded as a module. I'm not really aware of what this means exactly, and well, how you should proceed in the best way. But if you have a module, it means that loading that into your JavaScript context is not done as you would do otherwise. So you actually need to some special handling, and that's what I have yeah, I have discovered that you can actually, when you provide a script in your HTML content, you can specify that this is going to be a module instead of specifying that this is going to be JavaScript code. If we go and have a look maybe in the main file, which is view.html, so you see we have this module now, whereas for the other content you're going to specify, yeah, it's text JavaScript, even when you're specifying a source file, it's still text JavaScript. So module is a special case, and I'm not sure what this is doing, but at least this is allowing you to perform that. Import this from that other file, which is a key, because otherwise I could not find a way to get access to this Brotli decode function properly. And once you have that, it's still just inside this module, so we also really need to assign that to the window itself, so you can get access to the Brotli decode function outside of this module. But first thing I was trying here was to try to use this simple example, which I think is what I'm defining here. And yes, as I said, we use module, blah, blah, blah. And this is the example that I found on this page, I guess. Yeah, because of course, when I was starting, it was not really working for I don't know what reason. And I think at some point we have, yes, there's one. And that's working fine. So that's absolutely great. So with that in place, then I could move to the next part, which was to actually try to use this Brotli decode function to do the decoding of the file, I mean the content that I'm receiving on my request. And for that, I have updated my Qt loader. So first version was looking at that. The basic idea was to replace this fetch compile wasm function by a fetch compile compress wasm, which I have implemented completely. And if we go in the corresponding file, that's going to be Qt loader here. Let's go find the compress wasm. So what you do here, I still have this entry. I guess we could just, how about that, remove it. Fetch progress. Fetch progress is something I introduce a bit later, so let's not mention that for now. It would still work, in fact, if I'm not using fetch progress, but just fetch resource. So uncommenting that and commenting this line. But there is a interesting difference, which we will mention later. Anyway, we fetch the data and you get the response. The response at this point may not have been downloaded yet. You just get the headers, you may get some initial data, but maybe not the complete data for the full wasm file. So you could do streaming of this response and download data progressively and process the data chunk by chunk. But what we do here instead is we request the array buffer, and I have not really checked that, but the way I understand it, if you do this kind of request here, it's going to get all the data from the server before you can proceed with this promise. You say promise or promise, I don't know. Anyway, so you do the complete download, and when you're done, you get a buffer with the complete data, but this is still the compressed data. So what we do then is we turn that in a different view and unsigned byte array, and we send that to the Brotli decode function, and this is going to produce a decoded buffer, which is still an unsigned int 8 array. So you get the actual array buffer from this view to build a new response. I guess we could do that differently, because you don't really need a response structure. Maybe we could build like a blob, which is what I'm doing in fact in the fetch progress, but never mind. It's also working here with a new response, except that the response now contains a complete decompressed data. So there's no need to download anything anymore. And after that, you will proceed with the fetch then compile wasm. Actually, it's more like just compile wasm. You've already fetched that, right? Fetch then compile wasm. Where is this defined? Interesting, because then you get the array buffer. I could simplify that, in fact. And then you request a compilation, loading, and you return this compiled data. Okay, yeah, why not? Let's just save this because I think I made a very small change. What was that? Yes, commenting this statement. And this version was already working just fine. You get the compressed data here, and it's going to output your uncompressed data. And then you can indeed load the wasm file as usual. So that's super cool. And from that point, I wanted to try to report some progress when I'm downloading the file, because by default with the Qt loader template, it's going to just tell you it's downloading, compiling, and you have no idea how long it's going to take. So it can be a bit frustrating if you have a slow connection, like it's my case sometimes. So yes, to do that, I have at this point introduced this fetch progress function. So let's have a look at this one. Fetch progress, it's a bit like fetch resource, what do? We do the fetch first, and if the response is not awk, you have an error anyway. Then what do? You get the complete length of the content that you want to download, and then you get the reader for the body, and you have this function here where you just try to read some data per chunk, and you're going to keep a list of all the chunks that are read until the end. So when you have this function call, what do? You read some data, then you get if you're done or not, you get some bytes, and those bytes is an array of bytes. Actually, you push that as an additional chunk, you add the length of this chunk to your received byte, and then you can compare the received byte against a complete content length, so you know where you are in the download. And yes, from there you can just update the display message to report your download progress and the percentage at the same time. And yeah, when you're done, then you just return the list of chunks. And so and if you're not done, you read again, and then you call that once, and that's all you need basically to download all the chunks and report progress progressively. When you're done with that, then you get a list of chunks and you build a blob for that, and you return the blob. And in fact, the blob is behaving like a response, because in both cases you have this array buffer function, which is a promise on an actual array buffer, and that's why, yeah, we can just switch between those two implementations here. Then we get something, we can be a response or blob, and we call this array buffer on it in both cases. Yeah, and then we go again with this creating a new response. This actually will not work. Yeah, will not work if I try to replace fetch progress with wait a second. No, I mean, it's going to work. It has to work because I have a blob here. So those values are going to be undefined. So yeah, my response is actually partially undefined here, but nobody cares actually. So probably I need to optimize a little bit on this. Anyway, with this, I got my progress reported. And in this article, I'm basically explaining all this again. And then, yeah, it was time to try to serve that on my actual public web server, which was not quite working at first because yeah, I had some problem with the mem types. At first I was trying something like that for the location definition in the Nginx server, by the way, and was not really working, but the configuration was okay. But eventually, yes, I found that what I needed was more like this, which, if you think about it, is not extremely different, except that we use an alias instead of root, and we specify the index here. Not quite sure exactly why this was confusing the mem types, but apparently it was. It could also be that, yeah, maybe I need to upgrade a bit my version of Nginx. I'm not quite sure which version I'm using anymore. So maybe with updated version, this is not really an issue. I'm not sure. Anyway, what else? Yeah, was working great then on desktop. Because then I tried also on my mobile, and it was refusing to start the application. It's downloading and all, but then I'm getting an error because I cannot actually allocate the required memory for the application, and this was because by default so far I was allocating 1 GB of memory when I'm creating this application. Because when you use Qt in WebAssembly, one thing you need to know is you can activate support for multi-threading, so you can use multiple threads in WebAssembly. It's going to use web workers to give you multiple threads, but if you do that, you cannot use at the same time the progressive growth of your memory, because that is messing everything up. From what I understood, you must allocate all the memory that you want for your application at once at start of your application, and then you cannot allow growing this memory anymore. So there is normally a dedicated parameter for that to configure unscripted to allow growing the memory, but you don't want to set this if you also enable pthread and thread pool, I think. Yeah, I did some experiment on that, and not quite sure exactly what are the conflicting variables here, but that's the basic idea at least. Anyway, you have to specify your initial memory, but 1 GB is not really working on my phone, so I just tried to reduce a bit this memory to 256. And yes, with this setup, it's working just fine. I could load the application on my phone, and from that point, now I'm already using this application, and I made a few updates, but every time I do the update, it's still working just fine. I think we're pretty far from the usage of those 256 megabyte anyway. I think at start it could be using like 20 megabyte. I'm not absolutely sure about that, but I've got an error message when I was not specifying the initial memory with those numbers. And yeah, that's it. So it's pretty cool and working fine. I'm still working on this application, and in fact I'm preparing another article where I'm describing the update of the interface itself, because when you go on your phone, it's pretty different from when you can use interface on your desktop. So I really needed to update the interface to make it more usable on the phone, because that's where I really want to use this application in the end. But yeah, that will be for another part, and I think we're good now. It's already pretty long, so as usual, thanks for watching, and if you have any question, yeah, just let me know in the comment, and yeah, see you next time. Meanwhile, happy coding. Bye bye.